Okay, so now we are going on to the next lesson, and so we'll look at the next two properties of circles. So that's going to be property 3 and property 4. So in property 3, we're saying that the angles in the same segment are equal. So we will prove that here by using one of the last properties. We said that the angle at the center is twice the angle at the circumference. So if we're saying that this angle here is going to have to be 2 times this angle here at the circumference. Well, if that's true for this one, and that's true for this one, that this angle is also going to be essentially half that at the center, then these two angles must be equal. Now this one you can tell, so angles in the same segment. So how we're going to know that's the case is we'll be able to outline them. They will always begin and end in the same place. So for instance, this one, we're starting at A, going to P, and then ending at B. So we went from A to B. And for Q, we begin at A, we go to Q, and we end at B. So again, we are beginning for both of them at A and ending at B. That's how we know they're in the same segment, because they go from the same point from the beginning and they end up at the same point. So these two angles, angle P and angle Q, will be equal to each other. So that's that property. And then we have property 4, and then we have an extra that goes along with it. So what this property is saying is opposite angles in a cyclic quadrilateral are supplementary. So you might have a few questions about what that's even saying. First of all, opposite angles, so angles that are across from each other, and we're talking about in a cyclic quadrilateral. A cyclic quadrilateral means we have a 4-sided figure, that's quadrilateral, a closed 4-sided shape, and what makes it cyclic is that it touches, each of the vertices touch a point on the circumference. So this is a cyclic quadrilateral because it touches at all points on the circumference of the circle. Okay, so that's our opposite angles and the cyclic quadrilateral. The last thing we need to understand is what is supplementary. Supplementary means that it adds to equal 180 degrees. So opposite angles, so what that's saying is that x plus y will equal 180 degrees. The same thing, they don't have it labeled, but angle A plus angle C will also equal 180 degrees, giving us a total of 360 degrees, which is the degrees we have to have total in a quadrilateral. So why this is true? Again, what we're looking at, if this is the angle at the circumference, that means the angle at the center, that's this one, is going to be 2 times as big. So that's 2y. So 2y. And then we have over here, if this is x, then this angle at the center has to be equal to 2x. We know that a circle, if we completed this, is going to be 360 degrees. So we can say 2y plus 2x equals 360 degrees. If we divide everything by 2 to simplify it, we have x plus y equals 180 degrees. And we've just proved why those two angles, the opposite angles, are supplementary. So that's going to explain that one. And then as a little bonus on the cyclic quadrilaterals, we also have the fact that an exterior angle, this outside angle of a cyclic quadrilateral, is equal to the opposite interior angle. So that's the inside angle. And that again makes sense because this angle plus this angle have to give you a straight line, which is 180 degrees. So this angle, the outside angle, has to be equal as well to the opposite interior angle. So we can use these in many different ways. We're going to look at 2 of the examples that the book has so we can see, again, what you would see in a problem. Beginning with these questions, you will have to state why it is that your answer is what it is. You don't have to write a long paragraph, or you don't even have to do sentences, but you do have to state why it is that your answer is what it is. So if we're looking at page 333, we have a circle, and again, one of these things I mentioned before is what I'm looking at when I look at a question and when I look at a circle. And what I see when I look at this is a bow tie. You can see it's a little bow tie there. Anytime I see a bow tie, in my mind I'm thinking same segment, angles in the same segment. And so right away, that's what I'm going to be looking out for and filling in what I know. Okay, so they give us this circle. They tell us that, oh, and you notice there's no O given. We don't have a center. We don't need one for either of the properties that we just went over. We don't need to use the center of the circle. So they're telling us that this angle here is 78 degrees, and this one is 25. And they want you to find an A, angle PQS, and in B, they want you to find angle QPT. Okay, angle PQS. So again, I'm thinking same segments. If I begin at P, I can go to T and end up at S. I can also begin at P, go to Q, and end up with S. Again, I began at the same point, I ended at the same point. That means this angle is also 25 degrees. So angle PQS is 35 degrees. So that would be our answer. Why? Because we would say angles in same segment. That's all you have to say. You don't have to go into a long explanation, just angles in the same segment. Okay, the next question is asking you to find angle QPT. QPT. So we're looking for this angle. For me, right away, what I see is that this whole angle here has to be equal to 180 degrees. So I would say 180 minus 78 gives us 102 degrees. So I know that this angle is 102. I know this angle is 25. So if I add those up, I get 127, and I know the triangle has to have 180, so I subtract and get 53 degrees. Why do I know that's true? I would say straight line equals 180, and I would draw a picture of a triangle equals 180 degrees. So that would be my explanation of why that would be true. Again, it doesn't have to be this long explanation. We're just trying to say what it is, what I did. First thing I did was I saw the line, so I subtracted it. Secondly, I added my triangle, the angles that I did have, and subtracted from the total. Because triangles have 180 degrees. So again, not overly complicated to give my explanation of why I have found my answer. And then the second example that they gave you, we'll look at this cyclic quadrilateral, and we will see an example that has to do with that. Again, anytime I see a cyclic quadrilateral in my mind, I'm thinking, okay, opposite angles are going to be supplementary, and I'm looking for, if possible, if we have an exterior angle as well. So again, my kind of antennas are going up, metaphorically speaking, anytime I see specific shapes within these questions. Okay, so in this one, they're telling us that this is 33 degrees, and they're telling you this whole angle here is 100 degrees, and they want us to find angle ABD and angle DBC. Okay, so to begin with, for angle ABD, so that's going to be this angle here, right? Okay, so again, I know this one is not as obvious, but you always want to look for angles in the same segment. I'm beginning with A, I go to B, and I end at D. In this case, I go to A to C to D. Notice I began at A and I ended at D for both of them. That means that angle C is equal to angle B, so this is also 33 degrees. That one's maybe not quite as obvious as the other one. That's why you have to really be looking out for it. Okay, so always, again, look to see. It has to begin and end at the same points. So that one's fairly straightforward. So again, that would be same segment. We can write same segment. And that would be our answer. For angle DBC, now I want this angle. Now, what I'm doing here is I'm now looking at this whole angle plus this whole angle are supplementary. So we know that 100 plus 33 plus this angle, DBC, DBC equals 180 degrees. So if we said 133 plus DBC equals 180, we subtract 133, and we get DBC equals 47 degrees. And I believe that's what the book is telling us. Yes, 47 degrees. So the question then would be, how can we explain why? Well, we said opposite angles in cyclic, I'm going to say quad, are supplementary. I know this is a little bit more writing than the other ones, but again, I haven't gone hugely out of my way here. 1, 2, 3, 4, 5, 6, 7 words. I think you guys can handle that to explain it. But again, some of these are a little less obvious, so you have to take some time and think, what do I have and what do I need? They will always have to give you a possibility of finding all the angles that you need to solve the question. Some of them will be less obvious than others. This same segment one is typically a little less obvious than the other one. So if you're like, I have no idea how to solve it, look for something like that. Okay? So go ahead and begin working on the next section.